Good afternoon, everyone. Today in this video, we'll be seeing how to make a mounting bracket for a rotary gear assembly. This drawing is actually available online as well, and if you have a book on machine design, obviously you'll find this drawing too. Welcome to CSK Technologies. Let us start begin making this model. Now, coming to the general process which we follow is your drawing reading. In this, I have two drawings. This is page 1 and this is page 2. There are few dimensions which are assumed as per the assembly. So, this is my front view. There is a section view cut at the center to show us the internal features. And this is my right view. This is my left view for understanding of this feature, as you can see. This is a detail view for the cut, and in the next page we do have the back view for the supports and for the holes. Since all the dimensions cannot be given in one view, it might create a lot of cluster. Hence, the dimensions of a few features are shown in the front view as well. Now, let's start making this model. I'd like to start with the front view and considering this as my 0, 0. So getting into the start mechanical design, since we are working on part design, it's on part design. I have a pad command obviously to add material. We will try to check the views and simultaneously make the model. It should maintain the exact views as shown in the drawing. In machine design textbook, they have used the first angle projection. So before proceeding further, please try to check the angle of projection and then start working on your model. Now, the material actually is added up to 15. I'm saying this one is added up to 15. So let me try to add that up to 15. Now, next, I'd like to add the shape. If you can see the shape is actually added only till here, which is up to 2 mm. So I'd like to take it on this. Since it has dark lines, that means it's presented over here. In the next view, as you can see, it is hidden lines. That means it's not in the back view. This is in the front view. So I'm using the front view to create the same. And then I can use arcs, or I can use a circle as well. So let me try to take arc and then mirror it onto the other side. Now, the distance between this and this is 30 typical. That means both the circles are maintaining equidistant from the center. So I can give that as 30. Now the radii of this is 37, as you can see. So I'm giving this as 37. You can join these two by using your bitangent line. So I can just use bitangent line and bitangent line. Let me try to see if there are any openings or gaps. Since they are, let's try to join them together. This is my sketch. This is only added up to 2. I'll make this and cut later. So this is only till 2. You can see the feature. Now, you can start making the base, or you can start making this extrusion. But I prefer from doing the base, as you can see. So I'll be working on the right view. First, let me try to make a sketch of the view and then proceed further. Now, let me go back to the right view. You can also use H and V variation. As you can see, it's running from here, or you can also use the left view to create the shape, as you can see from here. Either way, whichever you're comfortable with, you can work on. Right or left, it's pretty much the same. I'm taking the arc from here and I'm starting, as you can see. I'll start from the inner side because the inner side is actually controlling the full body. Let me to go back to your right view and show it to you how it looks like. This is how it looks like. So we do have to maintain certain dimensions again. So let me try to take those as well. And then this is supposed to be 10 as shown in the drawing, which we have just seen. Now this actually has been offsetted to 12 to create this shape. So I'm just trying to use an offset command and do it rather than stressing out and doing it again. So this is my 12, and we do know that we are supposed to join them together, so we can just directly join them. This is the first join. While doing the second join, I would prefer R10 as the main one because that is the first reference I have, and I can join these two as well. Now this length is again 12. You can give this or you can constrain it as well. And say okay. Now let us see how much you're supposed to add this. This is added up to 70 as shown in the front view, but I'll use a mid plane. That means I'll have to give 35 on either sides. Now, while continuing the model, let us keep in mind to maintain the dimensions. The base is actually till 90 from the back face, that is from here. So instead of subtracting, I'd like to take a reference at the 90 and then use that as my reference for the modeling. Now I can actually maintain the 90 dimension as well as the exact dimensions of the rectangular feature. As you can see, the rectangle feature begins from the top, that is from here. So let's try to use this as a reference first and then start making our model, which is a simple rectangle, and start constraining it as per our drawing. First and foremost is maintaining symmetry. Second is the length, which is actually given as 130, as you can see, and the height is 15. So I'm just taking this as 15. Now, how much do you want to add it to? Of course, since we have made it on the new plane, you can add it up to the next or up to the plane. But instead what I'll do is I'll just select up to the plane and then select the face. So I'll know it can understand and add till then. Also, another important thing is if you move or make changes to this, the feature also auto updates itself. So that gives you a good flexible feature based modeling if you use these type of references. Now, continuing, I do have a feature here. I'd like to start from here and then slowly create this support and then create this support and then add the shape. This is the process which I'd like to follow, and then we can start removing what all other shapes we have. So to begin with, to add this, I have 46 and 50 and I don't know the overall length and everything. So what I'll do is I'll use shaft and then add the material because I know the overall 90 and the 46 and I can easily maintain it using the shaft rather than using my extrude or pad. So continuing, this is my reference. The reference is actually similar to this, the circle which is 30. It's in the same line. You can use that reference or of course you can take your own 30 dimension, but I use that. It's a little more easier for us to do it. Going back to your right view. This is another reference which actually we'd require. Now let's start making the actual profile of how we'd require the shaft. It goes this way. And I'm joining all of them together. Now, we know that this is 46, the inner cut is actually 45. So, they just got clubbed together. So, this is 46. Let me try to move it this way. And then the overall dimension. Again, the dimension is from this face and not from this face, as you can see. But this base dimension was from this face. So, I am trying to give this is 90. And you can see the dimensions. Now, let's try to give the diameters. This is 55. It's shown over here. This is 50, again shown in the same view. Exit, it tries to create a cylindrical shape. This is the cylinder. Now, you can actually give rounds here because since we are working on our supports, we can. There's a round actually at this location, if you can see R6. So let's try to give that and then proceed further. I don't think it can take R. Okay, it took R6. So warning. Now let's try to create the support. We do have a stiffener as a support, and I'm trying to make it on the right sketch itself, considering the right view. I would like to use my references of the circle and the edges. So what's first, let's try to take this edge. I don't need that, the base edge, and I would require these as well. So let me try to keep it in construction mode only and select this as my. The support is actually of this manner. Dimensions are given with respect to the center of the arc. So I'm actually trying to take it this way and then try to keep it here. There is no tangency over here actually. I'll try to delete that. Now the dimension from the center to this is 60. Similarly, the dimension from the face to the center is 32, or face to the line, the end of the line is 32. It's pretty much the same thing. Now we do know the radii, which is 25. So I'd like to give this as 25. And there is a vertical constraint missing on this. Now when I say exit, it will ask me how much is the support. Now while creating the support, the dimension of the thickness of the support is actually not given in this sheet, but when you scroll down in the under this, you can see the thickness of the support is 45. Let's try to take that as 45. This is your actual support. Usually before giving stiffeners, you can give rounds because the stiffener actually tries to take the shape of the round as well. Considering that, you can do it here too. For instance, there's a actually not here, you can do it here because there's a support which is coming there. So I can give it here as well, which is 4, and then you can work on it. There is another support here which I'd like to make it now. Again, I'm trying to make the sketch, selecting the right view. We are going to select the references as our requirement is, which is these 3. Actually, we can use the top line as well. This way as it goes. Now, while making, I'd like to use my line this way. Now, there is no dimension in this one, but in the second view, he has given the dimension that from this center to this is 60, in line with this. So I'd like to use that, that is from this center to end of this is supposed to be 60. I'm taking that as 60. Now when I exit, it tries to create the support. Now the thickness of the support is just 8. So when I am giving you the support, you can see that the round also takes the shape of itself on the corner. It is normally good to give rounds when you're doing these type of features. Now, last but not the least, we do have another shape over here in the left view. So I am taking the I'm taking the left view to show you where the feature is. This is my left view. The feature is located on this face. The feature is actually of this shape, as you can see. So let's try to make that. On this, I'd like to make a sketch. Now on the sketch, I'd like to start. So I would take a circle to start. I prefer this. I don't want to complicate it. And this is 48. There are 2 parallel lines going this way and that way. Now let me try to take a line and I use this as my reference first. Actually, there is an axis, but it has to be dependent on the face, because if we make any changes, it should auto update and maintain tangency to this. Similarly, I want the same line onto the other side and again maintain tangency. Now we do know the dimensions that the circle center is at 35 from this face, not from the back face. So this is 35. And the distance between these two is 105. The distance between this and this is 105. We need to maintain symmetry, which I will do in a minute. Let me try to delete these. Okay, we'll try to maintain symmetry with respect to the center. Give me just 1 second. Now let's try to maintain symmetry. This is your constraint profile. Now let's try to take a line as well, not in a construction one. Close this and add the material. Now, till where the material is supposed to be added to. When you use add, pad, till where is it supposed to add? So whenever you see the view over here, you cannot understand till where the material is actually being added. But when you see in this view, you can see that there's a hole which is drilled over here is up to the end extent. That means it's up to the feature of the stiffener. So you can add it up to the next surface if it can find, or you can select up to the selected. It usually finds up to next, This is how it actually adds the material. Now going back into your isometric view, as per our views, the model actually looks like this. Now let's start removing the material one after the other and then proceed with our rounds. I have given few rounds which are necessary for the model. Let's try to remove the shape first using a pocket. I'll use mirror and remove both of them in one go. I do have the ends which is at 40. So let me take a line over here and maintain symmetry. This is 40. Let's try to maintain symmetry. Yes. Now the same thing has to be onto the other side. I need to make a mirror option because there's a distance given for us. The distance between these two is actually 85. Again is shown in the drawing. This is the distance which is 85. From here we do have a little different shape which is forming. It has R10 first. From here it has R10 first. This is my R10. And then it has R28. Sorry, it has R28. And then again has R10 on the other side. This is my R28. It has to maintain tangency. And I have R10 onto the other side again. And maintain tangency. Now we do know this is R28, so let's try to give that as R28. And then try to maintain the 20. It's R28. Let's try to maintain the 20. That is from here till the end of this is supposed to be 20. Now the whole thing obviously should be onto the other side. So I'm just selecting all of them, mirroring it onto the other side and saying okay. Now this will remove the body. I want to remove it onto the other side, but up to the next. So it does it that way and removes the features. Okay, I think I've selected the wrong plane. I've selected this place. I want this plane. This is your cut. Now you can start drilling your holes. But there is a first internal cut over here. Let's try to do that. We can do that using a groove command, which is similar to your shaft. I am considering the right view again, using my references again. And let's start. I think the cut is till the end. So let me try to use this as my reference as well. Now let's start making the cut. It begins with 42 and ends with 32 till the end. I'll give the dimensions once I'm done. Now let's start taking the dimensions. This is 42 up to 45 cut, and similarly this is 32. I don't have to give the other dimension, it auto calculates it. Once I say exit, it tries to remove the material from the inner side. There is another hole at this location, as you can see, 32 depth of 47 with a V cut. So I can directly use a hole and do so. First, let's try to maintain concentricity with this two and say exit. Now let's try to give the dimension, say is 32 and the depth is 47. But I do not need a flat bottom, I do need a V cut. So you can see the V cut. This is your other hole. There are a number of holes as shown in the drawing. So let's try to go one after the other. There's one more here, which is 30 dia and 20 depth. Let's try to take that too. 30 dia, 20 depth. It's actually a V cut. You can see it in this view. It's a V cut. Let's try to give the shape and the position of it. The shape is actually given direct by default since I've selected the last time. And once I say OK, you'll be seeing that cut too. Going back into the normal view, there are few smaller holes which are shown over here. Let's try to take that. I can use a point pattern to do so. So I'd do that to make it less complicated. There are two holes here as well as here. First, let's try to take those. One, I'd mirror it onto the other side. And I'll just select these two again, then mirror it onto the other side. These dimensions are already given to me. 100 and this is 60. There are other dimensions also which is at an angle of 30 and are given. So let's try to take the 30 reference first from the center and then start working on it. So the difference between this and this is supposed to be 30, and obviously we'd require another R50 which is our reference. So I'm using the center arc as my reference and giving it, sorry, this is the reference, not that one. I'm using this as my reference and then giving the arc from here, assuming this is the center. Let's mirror this onto the opposite side too to avoid confusion, and then coincide this over here. The dimension for this is actually R50. Now there are points on this as well, so let's try to take those points too, which is at this location and at this location. Instead of repeating the whole thing again, I'll just be selecting these two and then I'll mirror it onto the opposite side. So I'll have 2 points here as well. Now when I exit, you can see that these points are there. Let me try to constrain this. I don't think it did constrain. These are my points. I have to give the holes at this location. So I'm just saying 8 dia at this point in this face. And dia is supposed to be 10. It is only up to the next face, which it can find, or I can also select the face and give it till with what face is it supposed to be. Now I can use my pattern and then directly select the pattern to avoid further issues. Not circular pattern, I wanted point pattern. User pattern and select the points. And say it till there. You can see the holes are actually dry. There are 2 more holes at 152 distance. Again, you can use point pattern or you can obviously use your normal sketch and also do it. Again, point pattern seems a little more easier for me. So I'm using the point pattern and I can give the distance and I can actually maintain the distance between these two as 152 if I use the point pattern. On this, I do have 2 into 6 holes. As you can see, they're only till here. So I'll just try to give 6 dia 2 holes, 6, and then select it only till here, not go further, and say OK. And I can either mirror or again use your point. Since point is there, I've used my point. These are your holes. Apart from this, now leftover things are your rounds. So you can give your rounds. These are 25 for this. You can just select all the 4 edges and give R25. This is supposed to be 25. There are rounds here as well. Let me try to give this round and not over there at this edge. This is actually R10. It's given over here, which is R10. So I'm just taking that as R10. This is one actually important round, as you can see. There are rounds at this edge too. When it goes over here, I think it's just 4 mm. You can just give it as 4 mm. These are your rounds. This is how you actually read and work on a model. I'm so sorry, I forgot these holes which are at the bottom. So let me try to take those as well before we exit the video. I'm sorry for the inconvenience. This is one sketch. Do have another one here. I can mirror them both onto the opposite side. There's a distance given actually which is 100 in between these two. So I'd like to take the distance between these two is 100. And another important one is the dimension between these two on the other side is actually 40. There is no top view given to us. So I am just trying to use the other views and give you the dimensions. This is supposed to be 40. And they are supposed to be inline. So I'll just try to coincide them. Or just make them inline. I'll use a reference instead. Let me try to use a reference. And coincide them on that. I should have done it after giving the dimensions. Now, these four are the dimensions. I can give a certain, I have to give a certain dimension here, which is not given there. So I'll just give certain dimension and say exit. Now I can drill a hole here. The hole is actually 4 into 10, which is through. Over here, I'll just give it as 10. And since they specified it to be through, I'll give that. Same way, I'll be using a point pattern to work on it too. These are the features. This is how you work on a model when you have multiple views. This is a mounting bracket for a rotary gear assembly. To learn more, you can subscribe and like our channel. If you're looking for more complex videos also, you can contact us. The details are given in the description below. Last but not the least, I do have one more feature to make. I'm so sorry again. I'd like to start it from this face. As you can see, there's a small slot cut in between this and this. It missed in the here. It missed in the flow of making holes. I can mirror it onto the opposite side, and the distance between these two is actually 2. It's a very small slot. That's probably why we missed it. So I do have around here. Similarly, I can make around here as well. This is supposed to be cut up to next. This side. This is your slot cut. Thank you for watching this tutorial. If you want more tutorials, please do subscribe to our channel. If you're looking for anything in specific, you can comment below. We'll look into it and make a tutorial on that as well. Thank you so much.